Hey guys, welcome to Wednesday. Your water cycle labs were due last night at 10 o'clock, so now if you haven't turned it in yet, that has become half credit. So hopefully you got that turned in. You had plenty of time to do it in class and over the weekend, and then you had time yesterday as well if you needed to ask any questions or email me. Today we're going to move right along. So yesterday we took notes in our notes packet on runoff and kind of all the vocabulary that goes along with that. And now today we're going to look specifically at streams and kind of what happens there. The picture of the day is actually from last year. I just didn't change it because I was short on time. It says a ruby sea dragon has been seen in the wild for the first time. So the picture on the left here is a picture of the actual dragon swimming around. It kind of looks like a seahorse, but they call it a sea dragon. And then this is what it looks like. You can see on the picture on the right what it kind of looks like they're just chilling out on a rock. So it's bright red when you get out of the deep ocean. So just something cool, a ruby sea dragon. I don't know much about the creature, but you're welcome to Google it and learn more. So like I said, today's plan is simple. The notes are a lot shorter today. Just short notes on streams. That's on page 7 in your notes. So we're going to do page 7 and page 8 in our notes packets. And then there'll be a worksheet at the end of class for you to complete on Canvas and get that submitted so I can get it graded. I know it's kind of frustrating relying on these videos for the week, but like I told you guys before, it's just the way that these trainings that I go to, they all landed 3 days in a row. So we're on page 7. Page 7 in our notes, we're going to look at a little bit more vocab having to do with streams and stream channels and just get some more vocab into our heads because we will be doing a lab about streams starting on Friday. So when I get back to you on Friday, we'll do some pre-lab stuff, and then Monday we actually get to go outside and make some streams, which will be pretty cool. So top of page 7. So stream channels, they have to start somewhere. They have to start at somewhere called headwaters. So the slide says the region where water first accumulates. That's your blank there. Where water first accumulates to supply a stream is called headwaters. So every major river has headwaters. They all start somewhere. This is a picture of where the Mississippi starts. If you've ever seen or been to the Mississippi, maybe you've been to St. Louis and you've been in the Mississippi, anywhere there in the Midwest, you know that it's a very large, very wide river. Well, this is what the headwaters look like. They start very far up north just because of some snow melt forming runoff. So the beginning of a river, wherever that is called a headwater. This is showing a picture of not only the Mississippi, but a picture of the Mississippi watershed. So if you remember from yesterday, a watershed is all of the land that runoff drains into. So in this case, all of this land drains into the Mississippi. So anything that drains in the Missouri River joins the Mississippi. Anything from the Arkansas River joins the Mississippi. Anything from the Ohio River all drains into the Mississippi. So the Mississippi starts way up here in Minnesota, way at the very, very top from snow melting, and then it builds as it goes down, and it's a huge, massive force of nature as it gets to those southern states. So all of the land is the watershed, and then obviously the headwater is where it starts. There's a ton of vocabulary this week with our notes. Here is kind of the watershed, more or less, for the Colorado River. So all of this land, one way or the other, joins the Colorado River. The headwaters, start up here in Colorado in the Rocky Mountains. So that snow then starts the drainage for the Colorado River. So the actual path that a river takes is called a stream channel. So it says moving water carves a narrow path in a sediment of rock called the stream channel. So that's your blank there for part 2 under letter A on page 7. This opening, the path that the water actually takes is a stream channel. Once the stream gets going, it's going to naturally make what's called a meander, or a bend or a curve. So what happens here is the water, as it's flowing through the channel, it comes in contact with a layer of rock that it can't cut through, a layer of a very strong rock. Maybe there's a layer of metamorphic rock or a strong igneous rock. And for some reason, it cannot cut through it, so it forces it to curve. So if the water's traveling up here, la 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 la, it hits something. Right here, it ran into something, and it got kind of bounced off and forced to curve through these rocks. And so the rock layers that we learned about first semester, the types of rocks, have a lot to do with the paths of rivers. Because when it bumps into something that it can't move, it just naturally turns, and that's called a meander. Now the meanders are going to vary a lot, having to do with a few things. So you're going to have to deal with the width of the river and then also the depth of the river. Those are both going to affect the speed of how it's going, and then it's going to affect its ability to carve a meander. So when you have a meander, this is going to be a big part of our lab next week. So here's a big part. So we're on letter B on page 7 in our notes. When water is moving along the outside, so that's your first blank, the outside of a meander, the water is going faster. Now there's a lot of physics going on here that we're not going to get to. You just got to know that the outside is moving faster, and therefore it is going to erode. You know that erosion and weathering is the breaking down and movement of particles. That's something we covered in first semester. So if you're new here for second semester, the word erodes means to move. So the water is going to actually move sediment on the outside. Then on the inside of the meander, it's the opposite. The water is, because of physics, going slower, and it's therefore depositing sediments from the water. So when the speed of a stream or the speed of water slows down, heavier objects like sand and pebbles, heavier sediments that are mixed up in that water drop down to the bottom. So deposit means to drop. So it gets deposited at the bottom of the river. This is a sketch. I don't know why your box on page 7 is so small, frankly. The things you want to really focus on is make sure you have deposition happening on the inside of the curve and erosion happening on the outside of the curve. So really ignore the rest of the words here. Make a meander. So you're sketching this. Make a meander, and then maybe even make a note for yourself that says the fast water is over here. On this case, this is the faster moving water, and therefore it's going to erode. And then this is the slower moving water on the inside of the curve that's going to get deposited. So make a little sketch. If it doesn't fit in the box, feel free to make it larger on page 7 because you've got a big margin there at the bottom. So as the water travels down the stream, as it hits that meander, this water on the outside is moving faster and it erodes. This water that's on the inside is going a lot slower, and then you're going to have things like sandbars there on the inside. And you've seen this. If you ever tubed like the Salt River, there's nice little spots that you can park your tube or park your kayak, and you can sit and have your lunch. The water's moving very slowly on the inside of a curve, and it moves very fast, and it kind of carves out this material on the outside of a curve. So make sure you have a picture on page 7 labeled with slow and deposition, and then labeled with fast and erosion over here. And then flip your notes over to page 8. Flip your notes over to page 8 when you're ready. Here's another picture that I didn't know was on here until now that is also very clear. I like this one because it kind of shows how the outside of the curve is cutting into the sediment, and over here it's cutting in over here. And then this gray color on this image is the deposition. These are your little beaches. This is where you would park your kayak and have your lunch, and then watch other people kind of cruise down the river. So a meander is naturally going to be faster on the outside and slower on the inside. So this is kind of a review for those of you who've been here all year. When streams lose velocity, they lose a lot of their energy too, and therefore deposition occurs. So this fills in your blanks at the top of page 8. So when a stream loses velocity, it loses energy and deposits, which just makes sense. In other words, slower water can't carry big sediment. So slower water can't carry boulders. Slow water can't carry big pebbles. They're gonna fall to the bottom of that river. This change in speed is going to cause a few features. The first one, so you have a little chart there on page 8 where it says feature number 1 is called an alluvial fan. Is when the water forms an alluvial fan. So an alluvial fan forms when water flows down a steep slope onto flat plains. So the picture that's on this slide is actually really cool. This used to be a waterfall. This used to be, there used to be runoff or some sort of water coming down the side of this hill. So just imagine that there's a fast-moving river up here, and then it drops down as a waterfall, and then it smacks into some sort of a slow body of water, maybe a lake or a pond. That fast-moving water loses a ton of energy, and when it hits this pond down here, all of the sediment drops. So what you're looking at is, let's see here if I can get rid of it. There you go. So when the water dropped, this is the pile of sediment that was released as that slow water hit when that fast water hit the slower water. You've got this pile of sediment, and this pile is called an alluvial fan. The vocab just keeps coming, guys. It just keeps coming. So the feature is alluvial fan. It forms, this is how it forms. It forms when water flows down steep slopes. And then you want to make some sort of a sketch. So the example I gave of a waterfall flowing over the side of a hill is a good example. I'd use that for your sketch on page 8. You have a spot to sketch. And the last thing for notes for today, number 2 is a delta. Oh, I love deltas. When I get back on Friday, I'll probably go on some sort of a rant about the Mississippi River Delta because it's just so freaking cool. So number 2 feature is a delta. This forms where a relatively large stream enters an even bigger body of water. So it forms where a stream enters a large body of water. The biggest delta, we have 2 big deltas in the United States. We have the Mississippi River Delta and we have the Colorado River Delta. Both of those are large. However, the Colorado doesn't actually hit the ocean in the United States. It hits the ocean in Mexico. So it's not really ours to claim, but it counts for North America. So the largest one, I guess, that we can claim really is the Mississippi River Delta. This picture is of the Nile River Delta. And so what it's showing is a satellite image of this white part is land. Oh, I need to get a different color. It's not showing up very nicely. This white section is all the land. And then this fan-looking thing, this is the actual delta. So when the really fast-moving water hits the ocean, it kind of smacks into it, and all of that sediment falls to the bottom. All of the sediment falls to the bottom. What's interesting about this picture is this is a picture of where the Colorado River hits the ocean. Now, sadly, very rarely is there any water. We have put numerous dams along the Colorado River for our own selfish purposes of gathering up drinking water and using it to make hydroelectricity. Like the Hoover Dam makes power for us. So we've dammed it so much and slowed down the water so much that on most days no water gets to the ocean. The Colorado River Delta is kind of just a big pile of sand. And every once in a while, if the stream flow increases, you'll get a little bit of water here at the end. So for your actual picture, I'm just going to click ahead to see if I have anything. For your actual picture, I would make it look something like this. So for your sketch that you have on your notes, I would show a river, and I would write that it's moving fast. And then I would show it hits the ocean. Oh, this is going to turn out horrible. Sorry, I should have planned this ahead a little bit better. And it hits the ocean. And when it hits the ocean, all of the sediment gets dropped. And so it makes sort of this fan-shaped pile of sediment. And it continues to build and build and build and build and build. So this is sediments that have formed when the river has hit the ocean. That's a really horrible picture. If I was in class, I would like to think that I would do that better. This is a cool map. All of the red marks. So to give you some perspective, here's Arizona. Arizona's off to the right there. Here's Arizona. Here's Nevada, here's California, this is the Colorado River, so the Colorado River up here, this is the Grand Canyon up here. It keeps flowing. Here's the Hoover Dam. If you've ever driven to Vegas, you have to drive over that. Then you've got all these dams all the way along. This is one that's coming from a watershed. And there's a whole bunch down here by Yuma. We have a variety of dams, slowing it down to the point where it actually, so when the Colorado hits Mexico and it goes through there, like I said, it gets to the ocean and it's dry. So we have slowed down the movement and we've collected it for our own reasons that it's normally dry when it hits, which is kind of sad. On page 9 in your notes, you have this picture. This is kind of cool. I want you to do this page with a friend, and then I will come back and look it over with you on Friday when I get back to class. So right now, I want you to follow the directions. It says label where deposition would occur, label where erosion would occur, where would the water be moving the fastest, and where would the water be moving the slowest. This I want to go over with you in class because it's a really, 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 really important topic that will be on your final for this semester, which I know is so, so far away. So I want to make sure that we all get that really good. So you're welcome to, when this video is over, to get up and sit with a friend, if it's okay with Mrs. Baptist, and work on page 9. And that includes this section at the bottom where you have to draw a cross section. Again, so a cross section is when you will have, you're going to show me that if you were to look at a bird's eye view of the river, what would the bottom look like? Where would it be lower because it's being deposited, and where would it be higher? I'm sorry, where would it be lower? Where would the water be deeper because it's being eroded, and which side would it be higher on? I just drew this real fast. I have no idea if that's right. Also, with that friend, you're going to want to answer, whoops, sorry, went ahead of slide. Oh gosh, what's happening? Okay, also with a friend, while you're sitting, you can ignore this portion. I forgot to delete it because I'm not there in class today. Sorry, no coupons, no coupons. You want to answer the questions on page 10. This gets you using all of your new vocabulary right away because holy moly, there's been a lot between Tuesday and today. Answer the questions on page 10, and like I said, on Friday, that's when I'll dish out some coupons for some answers. So having it done is just a benefit to you if you like to get your coupons collected up real fast. So do that. It shouldn't take longer than 5 or 10 minutes. Then your assignment is going to be on Canvas. You're going to look for the assignment that's called Stream Notes. There's a short worksheet to work on, and you can use that with the Canvas app if you want to, and just use the annotator on Canvas. If you like the Adobe annotator better, it's a PDF, so you can draw on it and type on it in any way that you want to, and that is due on Canvas tonight. So if you just want to get to the end game, you're like, Ms. Price, what do I have to do for my assignment? You have to do this. This is due tonight. You need to have pages 9 and 10 due by Friday when I see you in class again. So this is by Friday. So if you're looking to get everything done and ready to go, that's what you want to get done and ready to go. I will go over pages 9 and 10 with you in class on Friday, but you need to turn in the short worksheet that's on Canvas. Check the rubric, that way you'll know what I'm grading. There'll be one more set of notes tomorrow on groundwater. The timing is awful about all of these notes. It's just the way it's got to be. So get this assignment turned in on Canvas and be nice to Mrs. Baptist, and I will see you when I get back on Friday, and you'll hear from me tomorrow with another video. Take care and be good. See ya.